Well, Martin Rees, thank you for joining me for one of our interviews. So you're a scientist, you look at the universe, you look outwards at the stars. You're also involved in politics, you're part of our government. So given all of those very different things, is there an average day for you?
Well, it's of course changed over the years. You mentioned my career, and I started off being an academic with a focus on astronomy and space. I should say that I've always been a theorist, thinking about the stars and galaxies and how they got there, rather than doing observation myself. But I've been lucky to be at the Astronomy Institute here in Cambridge, which is one of the world's biggest centers for astronomy, where we have people who are using all kinds of telescopes on the ground and in space. But in my later career, I had the chance to get involved in a wider range of topics through being president of the Royal Society, our academy, and head of a college. So I have been involved not just in astronomy, but also in the rest of science, and also issues of education and all the ways in which technology affects our lives. That's a long answer to a short question.
No, it's a very interesting one. So you said there that you consider yourself a theorist on these areas. So what is it about being that theorist? Why is that important to you? Why do we need people like yourself doing those kind of things?
Well, I think over the last 50 years, astronomy has really been on a roll, because we've understood that our universe started from a big bang. We've discovered all kinds of objects like black holes and neutron stars. We've understood that all the atoms we are made of were forged in the centers of stars that lived and died long ago. And also we found in the last 10 or 20 years something that makes the night sky much more interesting, which is that most of the stars are orbited by retinues of planets, just like the sun is orbited by the Earth and the other familiar planets. And that's a really exciting new subject. And this makes us wonder, is there life out there, even intelligent life?
So you said that your background was physics and maths, but the backgrounds of the people that you work with must be very diverse to bring all of it together.
Yeah, yes. Well, most start off with physics and maths. One big change is, of course, the role of computer science, not only for analyzing huge amount of data, and it is huge. There's a satellite in space organized by the European scientists called Gaia, which has observed 1.7 billion stars. You can't actually count them without a computer. And so that's been amazing. And the other thing that we can do with computers is to do simulations. And if you're a particle physicist, you can crash together particles in the lab and see what happens. We can't crash together galaxies and stars, but in the virtual world of our computer, we can actually ask what would happen if two galaxies crashed together, or if stars exploded, etc. And it's the capability to do that which allows us to test if our theories are on the right lines, because we can make some assumptions, do a simulation, and see if what comes out is like what we see in the sky.
Fantastic. So lots of things all coming together there.
That's right, yes.
And you mentioned that one of the more recent discoveries was these planets that would be orbiting our stars, and you mentioned life there. So do you think it is likely that we will eventually find life on another planet?
Well, if it's there, we will, within 10 or 20 years, be able to get some evidence from the spectrum of some of these planets for whether there's oxygen or biosphere or lots of green stuff, etc. We can't do that yet because the planets are so faint. They're a billion times fainter than the star they're orbiting. So it's like looking for a far-flying extra searchlight. We can't do that yet. But of course, whether it's likely or not, we don't know. And the reason we don't know is that although we understand about the evolution of life on the Earth by Darwinian evolution over nearly 4 billion years, we still don't know how life really began. We don't know what caused the transition from complex chemistry to the first metabolizing, reproducing things we call alive. And therefore, we don't know whether that was a rare fluke or whether it would have happened in other environments such as might exist in other parts of our solar system or around these other planets. So I don't think we can place any confident bets. I think it'd be surprising and sad if there's no life out there. So I would hope for that. Of course, the question I'm always asked when people know I'm an astronomer is, are there any aliens? Is there intelligent life out there? And that, of course, is even less certain. And although it's worth a search for them, I'm not optimistic about detecting anything that we recognize as intelligent.
Okay. And you said there about the advances that will be kind of needed so that we can see these planets in more detail. So
Yes.
for the astronomers and cosmologists now and the new generation, what do you think are the key kind of research areas so that we will be able to look at those planets in detail?
Well, it's really bigger telescopes. There's going to be the James Webb Space Telescope going up in 2 or 3 years, which is going to be like the Hubble telescope, but bigger. But most important of all are the really big telescopes on the ground. And the world's biggest telescope being built now is in Chile. It's being built by a consortium of European countries, of which we're a part. And it's got the unimaginative name, the Extremely Large Telescope, the ELT. This will have a mirror which is 39 meters across. This will have the combination of sensitivity and resolution to be able to detect the light from a planet orbit.
And so going back a little bit and changing tack slightly, back to when you were in school, what were the subjects that grabbed you? Was it the physics and the maths, as you say your background is in?
Well, it wasn't. I think I was interested in natural history and big numbers and things like that, and biology, and I was very well taught in those subjects. But I think, to be honest, I specialized in the sixth form, and of course it's a great pity one has to specialize in English schools in science, because I was bad at languages. And so by doing sciences, I avoided having to do languages. And I'm afraid I've been lazy about language ever since. But then I turned out to be quite good at maths. And so I enrolled at Cambridge University, where I did my bachelor's degree in mathematics. I wish in retrospect that I had done a broader range of sciences, because I knew right from my first year that I didn't have the mindset of those who were going to be mathematicians. There were students in my year who clearly thought differently from me, and they were the ones who became mathematicians. But I learned some mathematics, and I picked up some physics and chemistry, etc., as I've gone along. But I'd have done better, I think, if I'd done what's called natural sciences, which is a range of science subjects which you can do as an undergraduate curriculum here in Cambridge.
So it wasn't, you didn't have a specific plan, a target to get into what you did. It was a series of
choices. No, I didn't at all. I mean, obviously some people who end up as astronomers were focused on it right from early childhood. I wasn't. And what happened was when I got my bachelor's degree in mathematics, I wanted to apply mathematics to something, because I knew I was better at sort of synthetic thinking rather than long logical arguments. So I didn't want to do mathematics. But then by a chain of accidents, really, I ended up in a group in the applied maths department, which was doing work in astronomy and cosmology. And this was in the 1960s. And I was very lucky. We had a very charismatic supervisor called Dennis Sharma. And he had a sort of stable of rather bright students. Stephen Hawking was 2 years ahead of me, and there were others in my year, etc. And we all learned from each other, and exciting things were happening. The first evidence of the Big Bang, the first neutron star, and the first quasar, and all that. And the advice I'd give to anyone who's going to do scientific research is pick a subject where new things are happening, new discoveries or new techniques, because then you can do things that the old guys never had a chance to do.
Excellent. Wonderful. Okay, and you mentioned your supervisor there, who was very charismatic. Are there other people in your life that have been very inspirational to you?
Well, I think I've been very lucky because when I got my PhD, I was able to have spells working in the United States and go to conferences, and so I was very lucky in that I quite quickly got to know many of the leading figures in my subject, and also in other subjects, and they have been inspirations, of course.
So for young people in primary school, late primary school, early high school, what do you think would be the ideal thing for them to be doing to start to get that feel for science, whether they were to go on to become scientists or just scientifically literate?
Yes, well, one hopes they will have some teachers who can inspire them, but of course your centre is so important because that supplements what they will learn in school, and also perhaps gets them close to the frontier, because the trouble of formal education is it starts with the basics, etc., which you have to learn if you're going to be a professional, but which may be rather boring unless you put them in a broader context. And that's why I think if you ask many people who ended up as scientists, they were inspired maybe by one particular teacher, but also by going to museums and by videos and all that. And so I think there are many opportunities outside school which are very important, and your centre is among them, clearly. Yeah. I think one thing I would say is that teaching in schools is very important, but there is a problem because those who live in city centre schools, they're not exposed to the natural world at all. They never see a dark sky. They've probably never seen a bird's nest. They may never even have seen farm animals, you know. So there is a big gap which needs to be bridged, if possible, by field trips of various kinds to supplement what could be taught in the classroom. And that's why, again, museums and science centres are very important, because they give people a perspective. Real things do have a special appeal. In fact, I remember looking back to my childhood, I had a biology teacher, and I still remember one lesson where he came in with a saucepan full of worms and threw a worm at each of us and got us to put it on a piece of paper and see how it moved and all that, you know. So actually seeing real things and doing real experiments is what sticks in your mind. And I still remember that lesson many, many years later.
So in other areas of your work, you've looked forward in time here on Earth and some of the challenges we may have in the coming years. How have you felt watching how people have responded to the COVID-19 pandemic?
Well, I think there are lessons to be learned from it. One is that we are in a global community where you can't have a disaster in one part of the world without it spreading around. And I think everyone realized that there were going to be these pandemics, there've been influenza pandemics, etc., and we weren't prepared for this particular one. And the question is how quickly we recover, and whether the advance of science will lead to vaccines and drugs, which will mean that next time this sort of thing happens, we'll be more prepared and it won't cause such disruption.
And that globalized world that you mentioned, which made it so easy for this virus to spread, also is a big strength from a research point of view and an industry point of view.
Of course, and science is the one truly global culture, of course, because protons and proteins are the same everywhere in the world, and we can collaborate, and science straddles all boundaries of nationality and faith. And in the case of the virus research, there's been already tremendous collaboration, and everyone is sharing data. The World Health Organization is helping, and I think we can be very grateful for these international communities of scientists and how they have prioritized this urgent issue. But it's just an exemplar of how science is a global culture.
Absolutely. Well, thank you very much for chatting with me. Okay, well, enjoy the rest of your day and stay safe.
Good. Well, good to be in touch.
Yes,
Cheers.
thank you very much. All right, bye.